Hi everybody. In this video, we're going to talk about the difference between deductive arguments and inductive arguments. And then we're going to identify some specific forms of inductive argumentation, because when we get to the point where we're writing our papers, all of those arguments that we're going to be focusing on are inductive. So the emphasis of this video is going to be on inductive arguments, but just for the sake of clarification, it's best to distinguish them from deductive. So here we go. So as I said, there are two main classes of arguments. And the first is deductive. And definition. A deductive argument is one in which we expect the conclusion to follow with necessity from the premises, or we expect the premises to support the conclusion in such a way that if the premises were true, the conclusion would have to be true as well. Whoever has written this type of argument or spoken it, or even just thinking, you can just use deductive reasoning in your own head, right? But the essence of a deductive argument, let's just imagine that it's on paper, is that if you just pretend for a second that the premises are true, the conclusion would have to be true, would necessarily be true as well. The argument from premises to conclusion would kind of add up like math. It'd kind of be like, well, if you got 2, and then if you added 3 more, you're gonna get 5. It's the essence of that type of reasoning, right? Which is known as deductive reasoning. Now, on the other hand, an inductive argument is one in which we expect the conclusion to follow only probably from the premises, or we expect the premises to support the conclusion in such a way that if the premises were true, the conclusion would probably be true, but not necessarily. So effectively, what you've done in an inductive argument is you've made a good case for the conclusion, right? You've provided a few good reasons in support of the conclusion, but those reasons, if they were true, even if they were true, wouldn't guarantee you that the conclusion were true. It would just give you good reason to believe that the conclusion were true. It would be likely that the conclusion is true. Okay, so there are some basic definitions. So, like I said, we'll take a quick look at deductive reasoning first. So here's 3 examples. Look at the top one here. Let me see if this pen works. Ew, never mind. Sorry about that. Techno disaster here. All right, look at the top example. Premise 1 is Bob has 1,275 songs on his phone. Premise 2 is, well, he just downloaded 5 more. Therefore, he now has 1,280 songs on his phone. If you pretend like this premise is true for a second, just don't have any quibbles with it. No qualms with it, right? Just go, if this were true, and if this were true, doesn't it look like that this would follow necessarily? Isn't the author of this argument trying to use that type of reasoning? Yes. See, adds up like math, and in fact is math. Or here's another example. All rattlesnakes are poisonous, and some of those snakes over there are rattlesnakes, so it follows necessarily that some of those snakes over there are poisonous, right? If these 2 are true, that would have to be true as well. Again, adds up like math. There's a real rhythm to these arguments. One last one. If you plan on drinking tonight, then we can't take your car. And you just said you plan on drinking tonight, so it follows necessarily that we can't take your car. See, again, if the premises were true, the conclusion would have to be true. Defining features of good deductive arguments. Now, just as another reminder, in this course, we're only going to be reading, evaluating, and writing on inductive arguments. If we're going to talk about an argument being inductive and describing the process of inductive reasoning, it makes sense when you compare it against the other type of reasoning. Right? So, one more time. I wonder why that's happening. Yeah, sorry, I thought this would be a cool thing to use, but it's not working correctly. So, we're focusing only on inductive arguments from here on out. Excuse me. So here are 5 forms of inductive or argumentation that are commonly used. Some of you may have studied this in a critical thinking class already, which is great, but we're starting at the beginning. So we've got prediction, argument from analogy, generalization, argument from authority, and causal arguments. They're all just different forms of inductive argumentation or inductive reasoning. Like, instead of thinking about them as absolutely discrete categories, like, well, if it's a prediction, it absolutely can't be a causal argument, or if it's argument from analogy, then no way could it be a generalization. That's a little misleading if you look at them absolutely in isolation like that. If you look at them as completely, what's that word I'm looking for? Oh, forget it. If you look at them as if they are exclusive from one another, there we go. Rather, once we start to just say, hey, look at that, it looks like a prediction, or look at that, it looks like a causal argument. Your method for figuring that out is what flavor pops the most. I mean, that's really the best way to look at all of these. Imagine that they're all ice cream, but these are they have just slightly different flavors, right? Got strawberry, I don't know what that, peach, French vanilla, pistachio, mint chocolate chip. But they're all ice cream. Similarly, all of these are just flavors of inductive argumentation. So we'll take each of these one by one and then run through a few. So let's look at prediction. Textbook definition. A prediction is an inductive argument that relies upon premises that deal with some known event in the present or past in order to draw a conclusion about the future. Right? So when you think of prediction, don't picture like a psychic or a soothsayer with a crystal ball saying, I predict this and that and the other. It's a common form of reasoning that we all use. We make predictions about the future based on what we know is happening now or what has happened in the past. So here are a few examples. Let's look at the top one. Every time I've come to school at 9 a.m. before, I've had trouble finding a parking space. And I'm going to school at 9 a.m. today. I'll probably have trouble finding a parking space. Right? So you're look, in the past, this always happens. I'm going to do this again soon. So I'll make this prediction. Or, in the winter, I always get an electrical shock when I get out of my car. and I'm about to step out of my car, I'll probably get shocked. So notice, let's take the bottom example for just a second. If it's the case that that in the winter you always get an electrical shock when you get out of the car, and if it's the case you're about to step out of your car, it's not necessarily going to be the case that you get shocked. Probably is, but not necessarily. So once again, I'm mentioning that necessarily, probably distinction in order to drive home the difference between a deductive and an inductive argument, and then I'll stop talking about deductive arguments. So next up is argument by analogy, and that's an inductive argument that relies upon similarities between two or more things or states of affairs in order to draw a conclusion. And so it basically claims that if two entities have certain characteristics in common, chances are they have one or more additional characteristics in common as well. So let's look at our examples. Top. The Acme Cafe and the Zenith Grill are both vegetarian, they're both Mediterranean themed, and they both have chefs trained at the Culinary Institute of America. Well, the Acme Cafe makes outstanding hummus, so the Zenith Grill probably makes outstanding hummus as well. So here, notice, in order to arrive at this conclusion that the Zenith Grill probably makes outstanding hummus, imagine if somebody said to you, well, why? How do you know? You've never been there. And you say, well, I know I've never been there, but here's how I'm reasoning. I know that the Acme Cafe and the Zenith Grill are both vegetarian, both Mediterranean themed, and they both have chefs trained at the same place. And I already know that the Acme Cafe makes outstanding hummus because I've eaten there a bunch of times. So considering everything that they share in common, the Zenith Grill is probably going to do just as well as them. Right? They probably make outstanding hummus as well. Now, is it a slam dunk that they're going to make, that the Zenith Grill will make outstanding hummus as well? No. They could put, I don't know, I'm trying to think of something disgusting to put it into hummus, but we'll just leave that aside. It doesn't have to be good based on these premises, but given what they have in common, it's likely that it's good. Or argument by analogy is used in, it's the basic principle of animal experimentation, right? So let's look at this one down here. Rats and humans have similar immune systems, and experiments have shown that rats exposed to cigarette smoke tend to develop cancer, so most likely humans exposed to cigarette smoke tend to develop cancer as well. So here, you're saying, look, rats and humans have something that in common that is extremely relevant to the conclusion, namely their immune system. And if experiments on rats are going to show this, then most likely experiments on humans would show that as well. And then really the ultimate conclusion behind this would be, so don't smoke. But again, this is argument by analogy. Now we're at generalization, and generalizations are inductive arguments that proceed from knowledge about a selected sample of a group to some claim about each member of the whole group. So, oh, yes, don't confuse the logical concept of a generalization with the everyday idea. What I mean by this is, you can often hear people just in everyday life saying things like, well, stop generalizing, or you're generalizing, and using that as an accusation, as if there's something wrong with it, just writ large. Right? Now, sure, there is such a thing as a hasty generalization. We'll discuss those in a future video, or stereotyping, right? But generalization is a fair and specific inductive argument form that very often just relies on statistics, rather explicit numerical statistics, or just the whole concept of most or almost everyone. Right? Let's look at some examples here. So, top example. The 3 sandwiches I have eaten from Mona Lisa Deli have been delicious. So most likely, all of their sandwiches are delicious. Put this, I know it seems a little stale when it's all broken down like this, but imagine how we talk just normally and how we reason normally. We do this kind of stuff all the time, actually. This is a pretty poor generalization, but it's a generalization nonetheless. Can you imagine if somebody said to you, hey, I just moved to town. Where can I get a good sandwich? And you are just thinking in your head, man, I've gotten 3 of those from Mona Lisa Deli. They've been killer. So, hey, you should go to Mona Lisa. They have killer sandwiches there, right? And in your head, it's just based on 3. But the point is, so like I said, this isn't a good generalization, but it still is one. The more important point for our purposes right now is that you're drawing a conclusion that all of their sandwiches are delicious, or most likely all of their sandwiches are delicious, based on a sample of 3. So you move from your sample to the whole class of things, right? And similarly with this example, 4 out of 5 dentists polled say that Crest toothpaste is the best for preventing cavities. So most likely the majority of all dentists say that Crest is the best for this as well. And that's really what they're trying to impress upon you when you hear this in a commercial, right? When they say 4 out of 5 dentists polled say that Crest is the best, they're not just, they mean for you to reason it out yourself. They're not just trying to say, hey, there's 4 dentists in the world that like Crest. They're trying to get you to do the math and say, well, if 4 out of 5 are going to say that Crest is the best, that means 80% of the dentists like it, right? Most likely the majority of them say that it's the best as well. But for our purposes at this juncture, here's the point. You've got a poll number, right? 4 out of 5. And then you extend it to the whole class, all. So it moves from how many out of a selection of 5, and you extend that reasoning to the whole class of things. And that's a basic generalization. Next is argument from authority, and that's an inductive argument in which the conclusion rests on the acceptance of some statement made by a presumed authority or witness. Very important argument form. So let's look at our examples. Let's take the first example and the conclusion first. Hey, you ought to stop smoking. Well, why? Because the Surgeon General has declared that smoking is bad for your health. Because this person said so, and ostensibly this person is an expert. Right? So you're not saying because it causes cancer or you'll get cancer in the future or whatever. It's saying because this person has said so. And this person, like I said, ostensibly is an expert or an authority, so you ought to stop. Here's another example. We'll take the conclusion again first. Hey, you ought to stock up on emergency supplies. Well, how come? Because the National Weather Service has issued a severe winter storm warning for the Southeast. Right? that would be an argument from authority, this being the authority. Why should I do this? Because this authority says so. Right? It's not like blind obedience to authority. We're talking about the way that people reason. We have to rely on experts for certain things. Although, yes, you can go outside and you can look and see a big storm coming, correct? Your eyes can deliver you that empirical evidence, but often when it's too late, experts have access to technology and predictive models that can give us a lot of, forewarning about these things. And they know these people spend their lives studying phenomena like weather. So you can take their advice, or same with the Surgeon General. Right? This is apparently the top surgeon or doctor that the nation has, or at least the one in the most obvious position. So to say you ought to stop smoking because our Surgeon General has said this is terrible, it's a fair way to reason. Another thing I can say about arguments by authority before we move on is, if you've ever watched a court case and you see when they bring up expert witnesses to testify on behalf of the prosecutor or the defendant, that's essentially argument by authority. And then causal arguments. Causal arguments are inductive arguments that proceed from knowledge of a cause to a conclusion about an effect, or from knowledge of an effect to a conclusion about a cause. Best understood or felt through an example or two. So, look at the top one. I accidentally left the milk in the car today for 8 hours. And it was 90 degrees today. Most likely, the milk will be bad. So, you're saying, ugh, the milk's going to be bad. Well, how do you know? Because I did this. I undertook this action. I left it in the car underneath these conditions, which are going to have the effect of the milk turning. This cause to this effect. Causal arguments, when they go from past or present to a conclusion about the future, often sound like predictions. Right? But before we move on, this is how you can tell the difference between the two. Predictions aren't stipulating any sort of cause to effect relationship. Their predictions just say, hey, something was going down in the past and it'll probably happen again. Or something's going down right now, it'll probably happen again. It's missing that causal element, that cause and effect reaction, right? But this one has it. Leaving the milk is the cause, milk being bad is the effect. Causal arguments. And down here, when I first went out to my car this morning, my front left tire was flat, and it was perfectly fine on the drive home last night. Therefore, I probably ran over something sharp right before I got home. Right? This one is reasoning from the present to the past. Or, sorry, that's a little bit misleading because it sounds like prediction. Let me take that back. This one is going from effect to cause. You notice the effect and you reason to the cause, right? Imagine if you were under these circumstances. Right? Last night you were getting home late, everything was fine with the car, tire's good, no worries. You go out to your car first thing this morning, front left tire's flat. What would you think? Right? You wouldn't just go, ugh, and walk away. You'd ask, how does that happen? What caused this? And then you reason to a conclusion. I must have ran over something sharp. Depends on what circumstances you were in, right? You might reason, oh, my ex-girlfriend's at it again, or whatever the case might be. But again, causal arguments, examples. Simple examples for all of these inductive forms in these videos. So now let's just move to some examples and answers. And by the way, what I'll do is put the argument up so you'll get an argument slide and then an answer slide. And I'll just give it a beat for you to try to work on it yourself before we move on to the answer slide. So again, all of these are inductive arguments, and so your task is to figure out exactly which kind. I've never met a golden retriever with a nasty disposition. I bet there just aren't any. This was a generalization. It must have been the pizza that made me sick. I was just fine before I ate it. This was a causal argument. Max always ditches his friends when he has a new girlfriend. He'll probably do the same thing this time around. That was a prediction. Bob stayed up partying all night. He probably won't make it to the gym at 6 a.m. That was a causal argument. When blue jays are breeding, they become aggressive. Scrub jays are very similar to blue jays, so they will probably become aggressive when they're breeding as well. Answers analogy. It must be the case that 60% of the students at that school are Democrats, since 60% of the students in one of those classes at that school are Democrats. Answers generalization. Like a watch, the universe is a complex system. We wouldn't think that a watch could come about by accident. Hence, we shouldn't think that the universe could come about by accident. Answers analogy. She can never get to sleep at night. Perhaps it's the 8 Red Bulls she drinks during the day. Answers that was a causal argument. She's going to need cataract surgery soon. Her ophthalmologist told her that her vision is going to get worse and worse by the day. Answer authority, argument by authority. So there we have it. Hopefully you got a preliminary familiarity with the 5 different common forms of inductive reasoning, which are prediction, analogy, generalization, authority, and causal, which doesn't mean those are the only types of inductive reasoning. They just help you, they're just identifiable flavors, let's put it that way, and commonly used modes of inductive reasoning.